Alright, when we're talking about increasing and decreasing functions, we're talking about the slope of a function, of a graph, on an interval. Alright, so if I'm saying a function is increasing, the slopes are positive. If I say it's decreasing, the slopes are negative. Let me give you a little picture describing this. Let's say this is my graph. Alright, now, you can see there's intervals where this graph is increasing and where it's decreasing. And here again, right here are your hills and valleys. Those are where your slopes are zero. Can you tell everywhere along this line up to that red dot, can you tell the slopes are positive? Can you see that m equals positive? And anywhere from this dot to this dot, can you tell the slopes are negative? Can you see from this dot on, can you see how all your slopes are positive? So this is called increasing from here to that red dot. This is called decreasing, and this is called increasing. That is what we're talking about when we say increasing and decreasing functions, or on which interval they're doing that. And increasing and decreasing is an important concept you'll see later in some other examples. So let's show you how to find intervals for which a function is increasing or decreasing. This particular one we're going to run into is increasing. So how do you do that? The first thing is find all critical numbers, because those are these breakpoints. That's where you might change, not for sure, but you will possibly change from increasing to decreasing or so forth. So to find critical numbers, we're going to take the first derivative and set it equal to 0, or find where it does not exist. So I'm going to take my first derivative, which would be derivative of x to the fourth is 4x to the third. Derivative of this right here is negative 36x. And what are we going to do with that derivative to find critical numbers? You set it equal to 0. Now, in order to set it equal to 0, I'm going to do a GCF real quick. So GCF of this is going to be 4x, it's my greatest common factor. 4x times what is 4x cubed? Looks like x squared. 4x times what is negative 36x? Looks like negative 9. And we're going to set that equal to 0. Now you don't have to worry about where this does not equal 0, or does not exist, I mean, because it always exists. This is a continuous function. Anywho, let's find the points where, for these two pieces, which will create a 0. So 4 times what will give me 0? That's the first piece. And what squared minus 9 will give me 0. So if you divide by 4, both sides, you get 0 divided by 4 is 0. So that's one critical number. My other critical number, when I add the 9 over, I get 9 squared, x squared equals 9. And then to get rid of a square, you square root both sides. So I get x equals plus or minus 3. So this and this, these are my critical numbers. Those are my breaks. Those are these points where I might change from increasing to decreasing. Okay, next step. Make a table with the critical numbers as the breakpoints. And here's what I mean by a table. By the way, on this interval, you're going to make a table on the whole interval. So let's see here. We're going to go, bam, we're going to make it all the way across this page. Alright. And we're going to have a breakpoint at 0, negative 3, and 3. So I'm going to put 0 right in the middle. That's one break. I'm going to put negative 3 and 3. Think of it just as it's a number line. Imagine it as a number line. Okay, those are my breakpoints. Okay, find the derivative between each point on the interval. So find the derivative of c, some value on this interval for each interval. So what would be a nice number to put from negative infinity to negative 3? What would be a really easy number? Well, I want to do f prime. Let's just do negative 4. What would be a good value to plug on this interval into the derivative? I think 1. It's probably the negative 1. 1 wouldn't even be in the interval. What about this interval? I think 1 would be the easiest to compute. It's all about choosing the easiest number. And for this one, let's just do 4. The smallest number we can that fits that interval. So let's calculate those and see what they are. All right, what is the value of each of these going to be? So when we plug in -4 to the derivative, I'm going to plug it into the blue function here. I have 4 times what, okay, that what is -4, and that's going to be times -4 squared minus 9. All right, so I'm plugged 4 in there and 4 in there, and what do you see I get? Well, this first piece is going to be a -16, and the second piece is going to be a 16 minus 9, which is 7. Now, does it even, what matters here, you could multiply that, but all that matters is it positive or negative? And what you'll notice is it's negative. All right, so what is the derivative at -4? It's negative. Okay, that's all we care about, because if you look at the last piece, if the derivative of c, of that -4, is less than 0, negative, that means it's decreasing. So for this interval, it's decreasing. I'm asking for increasing. So that interval is not part of what I want. So let's do each one of these. When you plug them in, what you're going to notice is the first piece. I'm going to have here, let's see, 4 times -1. So 4 times -1. I'm going to have -1 squared minus 9. That's going to be a -4 times a, what's 1 minus 9? Is that -8? What's a negative times a negative? Well, that's a positive. Okay, so is this going to be increasing? Why, yes. This interval right here is going to be an increasing interval because, as I can tell, the slope is greater than 0. So it is going to be an increasing interval. Doesn't matter what value I choose on this interval, because the only points that could possibly change, increasing, decreasing, are my critical numbers. All right, let's do this one. All right, 4 times 1 times 1 squared minus 9. So that becomes 4 times 1 minus 9 is -8. A positive times a negative, isn't that negative? Remember, you don't have to worry about getting the value, you just need to know if it's positive or negative, which is kind of nice. So that's decreasing because the derivative is negative, slope is negative. For this last one, we're going to go 4 times 4, and then 4 squared minus 9. So that would be 16 times 16 minus 9 is 7, which is a positive times positive, which is a positive. So what this says is we're asking for increasing. Increasing would be where this derivative is greater than 0. So what we notice is the two intervals for which we're increasing are these two. So it is increasing. My answer is increasing on which two intervals? Well, you're increasing on the interval from -3 to 0 and the interval of 3 to infinity. All right, that is your answer. That is the intervals for which you are increasing. If I want decreasing, it would be these. And those are the points where it changes. Those are critical numbers. All right, so again, you follow these procedures. First, find critical numbers, set your breakpoints up, plug a value within each interval into the derivative. People do the original function all the time. It's like, oh, please don't do that. Ugh. Into the derivative, and all you care is positive or negative. And then make sure you answer the question. Now, some people might say, why are they closed intervals? Well, the closed interval is actually kind of important. It's kind of weird, but increasing or decreasing is on the closed interval, except for infinity, because infinity is never closed. It goes on forever. So it's just kind of odd like that. But, all right, that's increasing, decreasing, and find out the intervals for which that is happening. There are other applications to increasing or decreasing. Here's one. Here's an application. Ready for this? Let's read it. The profit made by a business over a period of a year follows the function blank, where t is a number of months and p is the profit. On what interval is the profit of the business increasing? So, if that's profit, I want to know where the profit is increasing. So, according to what we talked about earlier, we need to find critical numbers. So we take the derivative of the function. Since that's profit, I got 6. So it's a critical number. Now why do I have 0 to 12? Because if it's a year, 0 months to 12th months, the 12 months altogether, it's my interval. All right. And then on the 6th month, all right, that is my critical number, my possible change of increasing and decreasing. And then what I do is I plug a value on each interval. I chose 1 for this interval, 7 for this interval. And when I plug it in over here to the derivative, I get positive and a negative. So what happens is your profit is increasing. Since this is a profit, my derivative is increasing. So I have increasing profits for the first 6 months. But then I have decreasing profits for the last 6 months. So the question answered is, I am getting profit increasing on the first 6 months. That would be my answer. An application. And in a business, it's nice to know when your profit is increasing and when it's decreasing. That's a very important thing to know. And it follows the same structure of what we just taught you.